Welcome to today's video. Today's video is for Advanced Geometry, Chapter 4, Section 7, using corresponding parts of congruent triangles. So this section goes nicely with Section 4. Both sections are about CP/CTC, but this section we're going to add a little more difficulty to it because the triangles that you're going to prove are congruent are overlapping triangles, or they might only be parts of other triangles or something like that. So if you take a look at what we're given that angle ZXW is congruent to angle YWX, and angle ZWX is congruent to angle YXW. Okay? And they've tried to label those in the picture, and if you take a look, it's kind of hard to see, because the little angles at the bottom are congruent, and then the big angles that are, the outside of those are also congruent. So when it says write a plan, what I consider that is what I want you to do is take the two triangles that you're trying to prove and separate them. Okay? So what I'm going to do is right above them, I'm going to draw the two triangles that I'm trying to prove are congruent. And this is WZX, and on the other side I've got WYX. Now, one of the nice things about doing this is you can now see the triangles that I want to prove are congruent. Once I prove those triangles are congruent, then I can use CP/CTC to say that the outside parts are congruent. One of the problems about separating them is sometimes you lose the aspects that you have when they're together. Like maybe you have a reflexive angle or something like that, that when you separate it, you don't see it as well. Okay, so if I relabel what I'm given, I have ZXW is congruent to YWX, and I also have these two angles on the outside are also congruent. So if you take a look at the picture I drew with them separated, you can see much better what angles I'm given, but if you take a look at the original picture, it's really easy to see that WX is reflexive. So what I'm going to do is I'm going to go up here and I'm going to label that as reflexive so I don't remember it. So I kind of look between the two. One of them is good to see what you're proving, and the other one is good to see any parts that overlap that you might miss when they're separated. Okay, so statement, reason. So this proof seems really hard at first, but really the only thing I need to say is that WX is congruent to itself by reflexive property. So WX is congruent to WX, reflexive property of congruence. Now once I do that, I have the triangles are congruent. So triangle ZWX is congruent to triangle YXW, and I have angle side angle, congruence postulate, and now I can say that the two outside segments ZW is congruent to YX, and that is CP/CTC. So in this next example, in the quilt, E is the midpoint of AC, so that's one of my givens, and of DB, so this one is also given. And I want to prove that triangle GED, so that's, actually let me make it a different color, a little easier to see. So I want to prove that GED is congruent to JEB. Okay. So this is one I'm not necessarily going to separate. You can separate it if you really find that really helps you do a proof and to see it, you can separate it. But for this one, what I notice is I have enough to prove that the big outside triangles are congruent. I can prove that AED is congruent to CEB. And I've got side angle side because I have the vertical angles in the middle, if I count the whole angle. Okay. Now once I do that, then I can use any of the corresponding parts of those big outside triangles. And I can use that to then maybe get those little triangles are congruent. So for this one, my first step in this proof is actually going to be proving that the big outside triangles are congruent. Okay. So I'm given midpoints, so I can say that AE is congruent to EC, and I can also say that DE is congruent to EB, and this is by definition of a midpoint. I can also say that the angle AED is congruent to angle CEB, and this is vertical angle theorem. And now I can say that the big outside triangles, so triangle AED is congruent to triangle CEB. Notice the way I labeled them because A up here corresponds to C down here. So make sure you don't label them as side by side. They're actually side by side and flipped. Okay, and this is side angle side congruence postulate. Okay. Now once I do that, now I can go inside and see what else I need to be able to prove this. So if I take a look, I have a side, but I can also get an angle. So this angle right here at the bottom is congruent to this angle at the top, D and B, because they're corresponding parts of those congruent triangles that I just proved. So I can say that angle D is congruent to angle B by CP, CT, C. And then the last one, if you take a look at these two interior angles, actually let me get a different color so you can see it again. It's yellow. If you take a look at this angle right here and this angle right here, they're vertical angles. And so I can say that they are congruent. So angle GED is congruent to angle JEB by vertical angle theorem. So now if I look at the pink triangles that I've labeled, I now have angle side angle for them, and I can say they're congruent. So I can say that triangle GED is congruent to triangle JEB, and this is by angle side angle congruence postulate. So a lot of the harder proofs we're going to do in this chapter are ones in which you're going to end up proving two triangles are congruent to use parts of those triangles to then prove other triangles are congruent. So this one I am going to do together, but I want to kind of give you an intro before we do it. So this one, we're given that CA is congruent to CE, and we're also given that BA is congruent to DE. And what we want to prove is that BX is congruent to DX. Now this is one where I think separating the triangles really helps you. So I actually did two separations. I separated, so I just have the inner ones, but I also separated the overlapping ones, so you can see those here. So this is another one where we're going to look at some of the bigger triangles and prove those are congruent, and then we'll get to the littler triangles. Okay. There's lots of ways to do this proof, okay? So we'll talk about this one. And I believe that is it for today's notes. Thank you for watching. Take care. Have a great day.